Let's look at some of the characteristics that we want our new telescope to have. One of the main things to think about is how much sensitivity our instrument will have. And you can think about this by comparing the sensitivity of the naked eye with the sensitivity you get if you use a pair of binoculars. The main difference is that your eye can only let in a small amount of light because of the size of your pupil, whereas with a pair of binoculars you have these very large lenses at the front. So one thing I definitely recommend is to use a pair of binoculars, maybe borrow them, and compare what you see in the night sky with your eyes with what you can see with a pair of binoculars. And you really will see that there's a very big difference in sensitivity. There's a very big difference in the number of stars that you can see. With a telescope, you get even more sensitivity, and with increasing size of the instrument, you get increasing sensitivity. So this was the original rationale behind the square kilometre array. This is how it got its name. By drastically increasing the collecting area of your instrument, you drastically increase the sensitivity. So what exactly are the advantages to having a telescope with greater sensitivity? Well, let's imagine that we've got a light source, maybe a star giving out light, and the light from that star is spreading out into space. If we're close by to that star, we will only need a small amount of collecting area in order to detect that star. But if we are twice as far away, then we're going to need not just twice as much collecting area to be able to detect the star as easily, but we will need 4 times as much collecting area. So the brightness of an object depends on the distance squared from it. And interestingly, that's exactly the same as Newton's theory of gravity, where the force of gravity depends on the distance squared. So we can see that more collecting area, more sensitivity, gives us a huge advantage in what we can see with a radio telescope. For example, at the moment, if we're just here, we might be able to detect radio galaxies in the nearby universe. Now, not all radio galaxies have the same brightness, but beyond a certain point, we're just not going to have the sensitivity to be able to detect them. However, if we have a greater collecting area and a greater sensitivity, we're going to be able to find similar radio galaxies to these ones that we see in the local universe out to much greater distances away. What's even more exciting, though, is that there may be whole other kinds of objects which emit radio waves, which present instruments aren't able to detect, that we will be able to detect with that greater sensitivity.